Okay, we're going to work on an optimization problem. So this is where we're trying to find either the minimum, maximum, or of some function. Okay, so first we'll read the problem. So find the dimensions of a 700 cubic meter cylindrical oil storage tank that can be made with the least cost of sheet metal, and assume there's no wasted sheet metal. Okay, so let's look over at our steps. So first thing you need to do is draw a picture. And if you come back over here, I actually have a picture, and I have a picture of a cylindrical oil storage tank. So, right, this is my cylinder. Okay. Identify the attribute that you need to minimize or maximize. A lot of times it's an area, volume, and length. So come over here, and I look, and I say, okay, I need to use min or maximize here, the least cost of sheet metal. And so it looks like we're trying to minimize our surface area. Okay, so that's step 2. The next step is write a function for the attribute you are optimizing. And optimizing just means minimizing or maximize. And it says I might have more than one variable in my function, so we need to write a formula for the surface area of a cylinder. Okay. Now it doesn't really specify if it's going to include the top and the bottom. Since it's a storage tank, I'm going to assume that you need a top and a bottom on it. So we're going to do the surface area for the entire the sides of it and the top and the bottom. Okay, so that means we've got to find the area of the top and the area of the bottom, and those are both the same, and they're just circles. Okay, so the area of a circle is pi r squared. Okay, but remember there's 2 of them. So for the top and the bottom part, it's going to be 2 pi r squared. Okay, so this is the top and bottom. Okay, so next we need to write the equation, write the surface area of this part. Remember, we can cut, if we cut it down the side and open it up, it's actually a rectangle. One dimension of the rectangle will be the height of the cylinder, so we'll say height. And the other dimension of the rectangle is the circumference of the base here, or the circumference of the top. So the circumference of a circle is 2 pi r. So that's the other dimension of that rectangle if you actually open this all up. Okay, so this is the area of the side. Sort of. I think I need to work on my handwriting. Okay, so now I can come back over here. So we wrote the function, right? So that was step 3. Step 4 is label the picture using appropriate variables, but we want to use the same symbols that we use in the function. I've actually already done that. We used R and H. Try not to use X, or it could get confusing once I switch over to the calculator part of this, okay? Because X is what we're going to have to put into the calculator, but your X could actually be your Y, so don't use X or Y in any of your variables if possible, okay? Try to use like either A or B or variables that make sense. So in this case, I'm using R and H. Okay, identify the constraint. It says this is usually the number that's given in the question. Okay, so my constraint looks like it should be this 700 because that's the number that's given in the problem. Okay, now just so you know, this is my function here. Okay, because that's what I'm trying to minimize or maximize. Okay, so now I'm working with the constraint. And my constraint says it's 700 cubic millimeters. Okay, remember cubic millimeters, well, that would be a volume. So that just means that the volume of my tank has to be 700 meters cubed. So there's my constraint. Let's go to the next step. Write an equation that relates the number in step 5 and the labels in the picture. So step 5 was that equation I just wrote here in purple. Okay. So now I need to write an equation that uses the R and the H. Okay, so what's the volume of a cylinder? Okay, most 3-dimensional objects, all you need is the area of the base times the height for its volume. So in this case, my volume is the area of the base, and my base is a circle, so that's going to be pi r squared, and then times the height. Okay, and then we already know that that has to be 700 because that's my constraint. Okay, now we're going to write in the, now we're on step 7. So we're going to solve the equation in step 6 for one of the variables. Okay, try to avoid square roots. Sometimes it'd be nicer to solve for the variable squared, such as r squared instead of r. Okay, that's if the function, remember the function's in red over on the other page. If your function only has a variable squared, there's no reason to solve for the r. You might as well just solve for r squared. Okay, so if I solve this equation for r, that's probably not very good because I have to substitute it in two places. One's r squared and one's r. Okay, if I solve it for h, I only have to put it in one place. So let's solve it for h, because looking at your function, that's going to be easier to plug just something in here for h versus having to plug it in for both r and r squared. And if I solve for r, I'm going to end up with a square root, which I'm going to try to avoid. Okay, so we're going to solve this equation for h. Okay, remember it's just, I don't care about this part right here already because the volume was 700. I put it in here. So h is the 700 divided by the pi r squared. Okay. Okay, now we're going to substitute the equation for 7 into the function that I have in step 3. Okay, remember my function's in red, what I just solved for, this is the purple. Okay, so I'm going to take this equation here that was in red, and I want to put this expression that I found in there for h. Okay, so now I got my surface area is equal to 2 pi r squared, okay, plus h, which is this 700 divided by pi r squared. And then that also gets multiplied by 2 pi r. Okay, since we're going to be doing all this work on our calculator, don't worry about simplifying this at all. You're just going to work with it like it is. Okay? So we actually got the hard part done. Now we're just ready to find where the derivative of the function is equal to 0. Right? This is back where in the section where we talked about that's where the min-max occurs, where the slope of the tangent line is 0. Okay, so your next step is we're going to put I'm going to put this function into the y equals part of your calculator. Okay, so I pull up my calculator screens. I actually already have them in. This screen right here is from the TI-84, and the screen down here is from the TI-83. So depending on which type of calculator you have, what it's going to look like. They're going to flip back and forth just because they're on auto refresh, so they continually give me the answer. Okay. Remember though, on the 84, we can build fractions, so that's what I did here. That's just using the alpha F1 command, and then I put the 700 over. And actually, I have a mistake if you notice. Hold on. All right. It should just be over, I wrote over 2 pi x. Okay, and then it should actually be 700 over pi r squared. Okay, so let me delete that, and this will be squared here. Okay, so once it refreshes, you'll see what it should be. Okay, and also you can't see over there, so let me scoot this over so you can see that the very end is just the 2 pi x. I think what happened is when I had it wrong, I was looking at this 2 pi x here. So what I actually want to make sure I remind myself over in this part is that the x that you put into your calculator is actually equal to the r. Your y is actually going to be your surface area. Okay. So let me come back over here. If you're on your 83, which again, that's the bottom one, just a couple things you need to watch out for, okay, on the 83 is make sure you have parentheses around just the denominator of this fraction, that's 700 over pi x squared, okay? So here's the beginning parentheses around the denominator. Here's my end parentheses around my denominator. This end parentheses is the end parentheses around the whole fraction. And then here's parentheses around that 2 pi x, okay? And then the form for the derivative is, you have that, this is in the math menu for both of these, right? The math menu is number 8, okay? The function you want the derivative of, the variable that's in the function, and you see that there's an x up here, okay? And the value, okay? So, but what we're going to be doing is for every value that it puts in for x, when I get over to the solver, it's going to put different values in for x, it's going to evaluate this derivative. Okay. So that's what this is what your two screens should look like. Again, the top one's for the 84 and the bottom one is for the 83. So if I go back to my 84, just if you want to check that you had the first part of it typed in correctly, or have it redraw that part of my screen for you also. Okay. And again, at the end here, it's just the 2 pi x. Okay, so now let's go into the math menu and over to the solver. Okay, and then what I need to do on the 84 is, remember, when we're looking for where the derivative is 0, so I'm just going to do, I'm on my 84, alpha F4, and we put the derivative in y2, okay? So I just want to know where y2 is equal to 0, okay? Same thing over here on my 83, right? Just hit the math button over to the solver. Again, we're looking where the derivative is equal to 0, okay? And actually that's what I already have. In case you forget to get the y2 on your screen there, right? That's where you go through the VARs menu. Okay, scoot over to yVARs. And then go to function. And then we're going to choose y2 because I put the derivative in y2. If you have your derivative in a different function, then you need to make sure you're using whichever number you put it in. Okay, and now I just need to find my answer. Okay, so all I'm looking at is, well, do we have a guess that we might use? We know it has to be bigger than 0 or I wouldn't have a cylinder, so maybe I should try, I don't know, around 10 or so. Okay, so I'm going to press alpha solve. Okay. I think I have the correct answer on the 83 already. Okay, so that's the 4.811. So let me come back. I'm sorry, yeah, 4.811 or 82, I should say. Let me come back over here. Okay, so remember my x is my r, so that means that my radius is going to be equal to 4.81. Okay, and we're in meters. Okay, but now what do they actually ask for? The last step should always be reread your question and make sure you answer what they ask for. I'm looking for the dimensions. So the dimensions would actually be the R and the H. They're not asking for what the surface area actually would be. Okay, they're just asking for the dimensions. Okay, I have that stray mark that doesn't actually belong there. I'm not sure I can use my eraser very effectively to get rid of it, just so you don't think that that's R squared or something. Okay, so that then means that my height is equal to, remember here's your formula for height, so that's 700 divided by my pi r squared. Okay. Now remember that r squared is actually still saved over here in x. Okay, so let me go back to my calculator. Second quit. Okay. And we're just going to, 83, I'm going to do 700 divided by, and don't forget I got to put parentheses around that denominator, pi, and then I'm just going to use x because it's stored in there and I don't have to worry about retyping it. Okay, on the 84, do the same idea. Okay, except now I can actually build a fraction, so alpha F1, and we're going to have 700 in the numerator, press the down button, and then pi x squared in the denominator. Press enter and I should get that same answer. All right, so 9.62. And that also will be in meters. Okay, so the dimensions of my cylinder that'll use the least amount of sheet metal, but it still has to hold to 700 cubic meters, will be a radius of 4.81 meters and a height of 9.62 meters.